Hello and welcome. Let me tell you about the work of the Uralmekhanobr Comprehensive Research and Design Institute. Today, Uralmekhanobr is an integrated mining, ore beneficiation, metallurgy, analytical chemistry and standardization institute, working to create unique technologies and industrial projects. Founded on the 8th of November 1929, Uralmekhanobr became the first Ural Sectoral Research Institute. Its founder and scientific director, mining general professor Mikhail Urtin, created a unique research and design school. In its 82 years, the Institute has conducted over 10,000 scientific studies of iron, copper, zinc, manganese, chromium, titanium, nickel, molybdenum, lead and rare and precious metals. The Institute has designed 1,350 industrial facilities and developed dozens of world-class technologies. The Institute's archives contain more than 2 million units of design documentation. The first step in developing new beneficiation technologies is to study the mechanical properties of raw stock and its molecular composition. Our analytical center is outfitted with various cutting-edge facilities and staffed by highly qualified specialists. This gives our clients a guarantee that information on the composition of complex mineral and technogenic materials is accurate. The individual characteristics of specific ores demand specialized approaches in respect of the methods used to study them. Our specialists use a wealth of chemical, physicochemical and physical methods, such as ICP spectrometry, X-ray radiometry and atomic absorption. Using these methods, we determine the composition of iron, copper, zinc, lead, manganese, gold, silver, silicon and other elements contained in the ferrous and non-ferrous ores, non-metallic minerals, dust, slags and other mining and metallurgical wastes. Once the ferrous and non-ferrous ores composition data has been collected, the material moves on to the Institute's Beneficiation Center, where the full ore dressing cycle takes place, up to obtaining the concentrate. It should be noted that many parts of the studying process are conducted simultaneously. Thus, in the course of analytical study, the ore also undergoes a test for its physical and mechanical characteristics. This allows us to determine the energy expenditure required to crush various types of ore, such as iron and copper ore. This relates to the need to evaluate energy expenditure at future or existing processing plants. As with any beneficiation process, the client's raw material is delivered to the crusher house of the plant, where the ore pretreatment process begins. Various types of crushing machines are used depending on the quality of the ore and the objectives of the study. Depending on the ore composition and the aims of the study, ferrous metal ores are broken down into lumps using dry magnetic separators. The resulting product can be our own crude ore, agglomerated ore, or tailings used in gravel production. Clients who want to lower beneficiation costs and can conduct pre-treatment at the surface mining site or inside the underground mine can use the X-ray radiometry separation method. The next ore pre-treatment cycle involves crushing of materials. Depending on the aims of the study and the quality of ferrous and non-ferrous ores, they can be crushed using the following: ball mills or rod mills, vertical or horizontal bead mills, rotary pulse devices and hydrodynamic generators. Now that the ore pre-treatment process is complete, we can move on to the ore beneficiation. Iron, manganese and chromium ore are dressed magnetically using rotary, drum, tubular and cassette magnetic separators with magnetic fields of varying intensity. The Institute has a large fleet of flotation machines. The Institute scientists use this flotation fleet to extract copper, molybdenum, lead, zinc, iron and other metals, and most importantly, to increase the scale of extraction. This is especially crucial in the case of base and complex ores. If the client provides us with precious ores or samples with rare disseminated ores, or if the client needs to refine production waste, we turn to gravitation. We concentrate copper, gold, platinum, tungsten, zircon and tantalum ore using gravity equipment such as the Holman table, Nelson concentrators and jigging machines. Water is one of the scarcest and most precious resources. For this reason, Uralmekhanobr Institute has been developing dry beneficiation methods for more than 50 years. Our excellent scientific knowledge base, newly developed technologies and cutting-edge research equipment fleet, which includes machines of our own design, allow us to beneficiate rare metal ores such as titanium zircon and tantalum niobium ore. Equipment used by the Institute includes the following: Itomac high-intensity magnetic roller separators and electrostatic corona separators. As a result, we obtain beneficiated ore without the need for a number of processes, thereby lowering manufacturing costs. The study of ore preparation characteristics ends with trial runs conducted at this mini processing plant, where the ore is further tested for several days in a continuous technological mode. Results of the study undertaken are compiled in the process regulations, which include a description of the technology and list the ferrous and non-ferrous beneficiation equipment required. The agglomeration and sintering laboratory. This is where we research the most effective ways of preparing the concentrate for smelting. The ore agglomeration and ferrous and non-ferrous metal concentration process is modelled in a sinter pot. The semi-industrial unit allows us to study agglomeration of iron and lead ores and nickel and zinc concentrates. The sintering process produces an agglomerate that is then tested using a special methodology. Smaller concentrates of ferrous and non-ferrous ores are usually subjected to pelletization using a drum or pan pelletizer. The resulting pellets are fired in a bowl furnace type laboratory unit, which allows us to recreate the roasting process of a horizontal grate machine. In non-ferrous metallurgy, where the agglomerate hardness requirements are not as high, we often use ore briquetting. The results of the study undertaken are compiled in the design and operations documentation used for the construction of manufacturing facilities. The design division of the Institute employs 250 highly qualified specialists, including mining and construction engineers, along with metallurgy and beneficiation specialists. The Institute is equipped for the full production cycle. The mining department develops surface and underground mining projects. The beneficiation department handles the ore dressing process. The metallurgy department and the chemical technology department design metallurgy facilities and sulfuric acid production lines. The Department of Senior Project Engineers and 16 other general engineering departments employ thermal engineers, electricians, economists, ventilation specialists and ecologists. Once the process regulations and main equipment selection have been finalized, the technology department creates construction and layout solutions for new mining and processing enterprises, which will be put into operation to supply raw materials to ferrous and non-ferrous metallurgy plants. We have just finished designing layout solutions. The construction department designed the foundation, walls, roof, electric power grid, heating and engineering infrastructure for beneficiation plant equipment. Step by step, all parts of the project converge in the department which deals with the issue and storage of documentation. The project is accomplished, and soon it will serve as a springboard for new industrial giants and unique production plants. Uralmekhanobr is an integrated research and development engineering institute, specializing in mining, mineral dressing, and metallurgy. Our intellectual work fosters effective technologies and projects. By ensuring an optimal level of expenditure and the high quality of the end product all along the supply chain, we help our clients develop their strategic advantages and come out ahead regardless of the stiff competition out there.